Alrighty. Well, welcome. You guys made it. Day 3. Are you all as tired as I am? I was a little worried that when they scheduled us in this room that it would be either too small or that I would be like that band that shows up and the only people out there to see the band, is the band members' girlfriends and spouses and friends. So it's encouraging to see a lot of you guys out here for kind of more infrastructure and operations kind of stuff. So this talks about improving Hadoop cluster performance via Linux config. My name is Alex Mount Alexis. I work for Cloudera. And the clicker is not working. All right. That's all right. We will switch out the clicker. So I use this to pimp another thing that's going on. The fireside chat's going on right after this. It's a very complimentary talk to what's going on here. Both Intel and Dell are talking about how to improve kind of your hardware config and tune your hardware for Hadoop config. So if you've got time after this, they'll be outside at Fireside. All right, let's see. So what do we got? All right. So tips from a former systems administrator. I came up doing systems administration. For those of you who know, how many developers do we have in here? Like MapReduce developers. How many kind of sysadmin cluster running people? How many of you are doing both? All right, good mix. All right. So if you've been an SA for long, you kind of know where I've been. I've racked and stacked systems, crawled around under floor tiles, had to undo all of this mess of cabling. You've been there, you've lived it. I don't do that anymore. I don't get as dirty as I used to, at least not physically. Now I'm a field guy. I work for Cloudera. I travel around kind of helping customers adapt to this new Hadoop thing, kind of holding their hands a little bit, helping them get used to things. So I live out of a suitcase in some hotel somewhere, usually, and my hair always has this beautiful in-house shampoo kind of look to it, because you can't bring your own stuff through TSA. So this talks mostly about really, really easy stuff that you can do to get more out of your Hadoop cluster, mostly through Linux tuning. And I say these steps are easy because they're well documented, they've been around forever, there's nothing horribly complicated, yet most clusters that I see, dozens of clusters every year, don't do these things. And I understand, I used to be an SA, right? I mean, we get excited, someone's downloading the new, Game of Thrones onto the server down the hall, and you're gonna go watch that later, and you're like, oh, I'll make these config changes later, and then you never do. So we get excited, we skip things, we forget, it happens. So if there's any takeaway from this, hopefully we'll be able to make some improvements to our clusters. One note, I do have a single summary slide, so for all of you who are taking photos during talks the rest of the week, you don't have to do that. There's one slide you can take a picture of. It's got a link to SlideShare directly on it. Have everyone else's experience be better, and we can skip all the photos. So, real quick, this talk is not about any of these things. There are a lot of amazing talks about deploying Hadoop and how best to do that through various automation tooling. Again, sizing and tuning depends heavily on what you're doing. We're not going to really discuss specific use cases today. And I'm not a coder, right? I hate Java. It drives me crazy. I've seen more Java error messages than I would care about. We'll do a little bit of fancy standard out redirection maybe later, And I'm not a big math person, so we're not going to talk about Mahout or anything machine learning. It's all really basic stuff. And it all comes down to this, right? Everyone asks you questions about how are we going to do this with Hadoop? And the answer is almost always it depends. And this quote is not attributed because I'm the one that says it all the time to my customers. They're always asking, well, how do I do this? Like, well, what are you trying to do? What are you using the cluster for? Because the answers to how we configure our clusters depend wildly on what we're going to be doing with them. So we're about 10 minutes in, and we're on slide 10, so that makes works. So what are we talking about? 7 things, real simple. Quick, safe, easy to implement on Linux. I don't have any Windows slides. I'm not apologizing. And most importantly, most of these things we're talking about today are things that are viable for any use case. So any cluster that you run, well, I should say most every cluster you should run, these things will be viable for your instance. So we're going to identify a couple of issues and then offer solutions. And most of these things do require some sort of root privileged access. to implement, since we are dealing kind of with low-level kernel hardware kind of stuff. So, number one, swapping. First of all, let's just not swap. Let's not do that, right? So swapping, for those of you who may be new to computing, is a form of memory management. If you remember the days of Windows, when Windows started going multi-window, you would change a window and you'd hear this grinding, screeching noise coming from your hard drives. It's because there wasn't enough memory to handle all the applications, and they decided, we're not using memory right now, we'll write that memory out to disk, and then we'll grab it later. So, and then you could use that now free memory for other things. So it's also known as paging, and there's a bunch of different implementations of this, swap files, swap partitions. The problem for Hadoop is that disks are really slow. And Hadoop is all about turning systems into a gigantic I/O platform. You want to drive as much I/O through those disks as possible, and you don't want to spend any more time grabbing your data than you have to. And so if your kernel is pausing to kind of write out stuff onto disk, that's time that you can't be reading data off your disk. Same time, that's time that you can't be doing processing using that data. And on a practical point, our memory usage within Hadoop is based on JVM. We can tell the JVM, use 1 gig of memory, use 2 gigs of memory, multiply by a number of mappers or reducers, and you should have a pretty good idea of how much memory your system should be using. So we should be able to block things up nice and cleanly. So we disable the swap in the kernel, or at least as much as we can. And the way to do this is pretty simple. We just basically turn it off. There's a proc setting called swappiness. We just append 0 or write 0 to that value. And then we also write a line out to our sysctl config file to enable that persistently. There is a little bit of peculiarity. This has changed recently. The kernel developers decided that, I guess before CentOS 6.4 and Ubuntu 10.10, that swappiness to 0 didn't really mean 0, and now it does. So that behavior has changed just a little bit lately. And there's a really, really good blog post that's linked to at the bottom. It's actually by a MySQL kind of developer guy who details really well what changed. And we're actually still kind of debating within the Cloudera walls whether or not we want to set that swappiness to 0, or whether or not we want to set it to 1, or what we want to do. Suffice to say, it shouldn't be 60 or 70, or whatever the default is for Linux. It's entirely too high. So setting it lower will reduce the likelihood the kernel is to swap data out to disk. Number 2, file access time. So Linux tracks access time for every write that you do to disk by default. And even if you just read a file, that's now a write. So every read becomes a write. And the problem with this is you're doing more disk seeks, right? You're not getting that rotational efficiency off your disk if you have to stop, write something to superblock, come back. And HDFS, is a write once, read many file system. And the name node tracks all of this stuff for us anyway, so why have the OS do it for you? It's duplication, and it takes more time. So the way to turn this off in your SSTab file, you just add the no A time option to your mount options. And you'll see in the literature, some people say, oh, you need to do no dir time as well. And no dir time is actually included as part of no A time, so you can just do the one option in there. If you want to make it explicit, you can put both. It doesn't hurt anything. Rel A time is kind of different. It's kind of like modification-only time. You'll see that's coming to be the default on a lot of kind of user-facing systems. But again, for our data disks, specifically our data disks, we don't need to track access time on our files. And you can just remount the volume. You don't even need to reboot, and you're off to the races. Number 3. So when I say get more out of your Hadoop system, really, it's not just about getting more performance out of the OS. It's having your cluster available to do more for you. And one of the big paradigms with MapReduce is you can run the same algorithm, throw more data at it, and you're getting more insight out of that. You don't necessarily have to have a better algorithm. Sometimes you get better results just by throwing more data at the problem. And so usually the more space, the larger your cluster, the better results you can have. So by default, Linux file systems reserve 5% of all disk for root-owned files. And I guess not everybody knows that. And it makes sense, if you go back, it makes sense on the operating system. If you have a kernel panic, you want to be able to write out that data somewhere. You need room for log files, you need room for anything else root might be doing. And disks used to be smaller or larger, well, or largely small, smaller capacity but larger. And we had fewer of them. There may only be one disk in a system, and so you would need to reserve that. And that's not the case anymore with servers today. You might have 6 disks, 12 disks, 24 spindles per system. We don't need to reserve root space on all of them, especially since HDFS doesn't run as root. On an HDFS data node, there should be no root on files whatsoever. And so you can do the math. If you've got a simple system that's got a single terabyte disk, it's 46 gigs you're leaving on the floor. It's never going to be touched. When you add that up, 5 disks per server, 5 servers per rack, it starts adding up even bigger, even faster. You start having multiple racks, all of a sudden you're leaving a pretty considerable amount of space on the floor, never to be used, never to be seen. And, why? So, when creating the partition, we can just set this little variable. I'm not sure why it's -m. It makes no sense to me. I guess -r, root for reserve. I guess that was taken by something else. But basically, you set the root reserve to 0. You can do this.
M means number of days to run FSCK on the mount. That's R.
Oh, all right. So R is the number of days to run FSCK on the mount. So thank you, taken. So you can do this when you're creating your partitions, which is really simple, or you can do it after the fact using tune to FS. I recommend 0, no root reserve. Some people are a little more hesitant about that, and they prefer to go a little more safe with 1 or 2 or something like that. It's fine. As long as you reclaim some of that space, it'll be made available to you. Name service caching. So the name service cache daemon is a service that runs in memory that caches all kinds of name service requests. Host names, passwords, group, net group. And the goal of this thing is to help weather network hiccups. If you've got an extremely high latency LDAP lookup somewhere, you don't want to hit it every time, it'll come out of memory. It helps a lot when you have remote kind of services, DNS, NIS+. Really small footprint, doesn't require any kind of config whatsoever. And the thing about Hadoop is that Hadoop is entirely based on remote RPC. It's largely network-based. You're on the network all the time. If you have the unfortunate need to actually do a TCP dump of your Hadoop network, I apologize. It's awful. It's on the network all the time. It's issuing all kinds of name lookups to hit data nodes, to hit the name nodes, to hit region servers. And if you've got upstream DNS and you don't have a local DNS server, you're thrashing your boxes all the time. You're thrashing your DNS server. So reducing latency of those service requests, smart idea. You're going to get better cluster performance if you don't have to wait a long time for name lookups. And at the same point, you want to reduce the impact of any shared infrastructure you may have. You may have local DNS servers on your cluster, but why hit them if you don't need to? Your cluster hosts aren't changing that often. So it's pretty simple. You basically turn it on. This is the Red Hat example or CentOS example. I don't have the Ubuntu, but I'm sure it's just as easily simple. Turn it on, start it up. You can check on it later, get some statistics if you want to, but most people just fire and forget. One note, if you're doing Red Hat SSSD, you actually have to modify your config first. Don't have it cache password group or net group information. You will have lots of headaches. And there's a lot of information about that at the link below. Number 5, file handle limits. So file handle limits are not a problem until they are. The kernel refers to all files and paths via handles, an integer in the simplest case, also known as file descriptors. So Linux started from Unix, which was a multi-user system, and the systems needed a way to prevent users from doing horrible things, either inadvertently or dangerously. You're writing a lot of C code back in the day, you open a lot of file handles, you don't close any of them, all of a sudden your system's out of file handles. It's not good. So the file handle limits protect the system from these kinds of problems. Problem is, Hadoop uses a lot of file handles. It's a file I/O-driven system. It uses I/O all the time. It opens a lot of files when it's reading and writing and doing all its things. And the Linux defaults just aren't enough. So the default is usually 1024, which for a typical user, individual logging in the system would be fine. But for a programmatic service that's using I/O continuously, it's not enough. So we recommend updating your maximum file handles up to about 32K. Some people say 64, depending on what you're doing. Start with 32. And while you're in there, go ahead and increase the number of maximum processes that each user can have as well. Just some real simple appends for each of your service users, HDFS, MapReduce, and HBase. And if you are running Clutter Manager, this actually gets done for you, so you don't have to redo it again. There's only 2 product pitches for Clutter Manager in this whole talk. That's one of them. So try to keep it pretty agnostic. Number 6. And this actually flies in the face of something I heard at someone's talk yesterday. But use a dedicated disk for your operating system and logs. Don't be tempted to share, even though you have enormous spindles these days. So here's what happens. You get a brand new server, rack of servers. It's got a whole ton of terabyte drives. You're going to store data on 11 of them. You've got this extra drive. You're going to put the OS on it. That takes about 20 gigs. And then somebody walks in your office and says, well, hey, there's 980 gigs here. Why don't we use this for data? And you're like, well, all right, why not? Wasted space, right? Seems okay. And then that person comes to you later and says, well, I don't get it. Like, I run this job 3 or 4 times, and now it's wildly inconsistent, and there's weird things happening, and I don't get it. What's wrong? We don't like shared disks with Hadoop. Every time you start writing stuff to data disks, the same spindle, we're interrupting our quest to get that data as fast as we can. And Hadoop logs are extremely verbose to begin with. They're writing logs all the time about things they're doing, things that's going wrong, things that's going right, hopefully more right than wrong. And it's really chatty. And every time your user logs in, every time some guy thrashes the network, and IP tables goes crazy and logs a bunch of stuff, that's time that's spent interrupting your disk I/O for Hadoop. And again, disk speeds are slow. Every time, every interruption, that's time we could be spending reading data we want off a disk for our jobs. So it's real simple. At install time, just dedicate a disk to the OS and logs. You can do different partition for OS and logs if you want, but make sure it's all in one spindle, and then use the rest of those disks for your data. After install, it's a little more of a mess. You can do, this is one thing that Hadoop is missing, is a good way to do manual block rebalancing on a single box. But manually, you take down HDFS, you quite manually move a lot of stuff around, and then you restart HDFS. And if you're really quick, you can just do it per data node. Depending on how much data you have, that may not work. May not be an option for you. Number 7. This one is so important. I don't know why it's not number 1. Name resolution. And by name resolution, I really mean DNS. You have 2 options. Use a host file if you have to. Not recommended. If you have a couple nodes, 2 or 3 node test cluster, all right, I'll give it to you. If you've got anything more, please use DNS. There is a third option here, which is not on the list, and that's just to use IPs all the time. Don't do this. So for those of you who have never seen a host file before, this may come to as a shock. It's a text file. Number 1 thing about host files, make sure your canonical name is set properly. For those of you who don't know much about DNS, the canonical name is the thing in red there. The very first thing, the very first name after the IP address is the canonical name. Make sure it is your fully qualified domain name. Do not set it to the short host name like below. You will get weird things that happen. Also, make sure that localhost resolves to, or that 127.0.0.1 resolves to localhost, not the host name. This will also screw you up. The right way to do it is right there. The wrong way is there as well. Don't do this. With DNS, you need forward and reverse. Do not forget the reverse. You will get headaches. And the host name should match the full, so your host name of the system, the actual box, if you type host name on the box, it should match the fully qualified domain name in DNS. For those of you who have never looked up host names before, this is what it should look like. If you looked up www.cloudera.com, you get an IP address. If you look up the reverse of that, you get the exact same name back. And this is the behavior we want. We want sane name resolution, both forward and reverse. This seems really simple, and I see some people shaking their heads, but almost every single cluster I've seen has this screwed up somehow. And it ends up, it happens all the time. When it mismatches, you will see problems starting data nodes. Your data node will just say, I'm not going to start, and it gives you this weird, obscure message. You don't know what it is. It's a name mismatch. You'll get non-fully qualified domain names in your UI links, which may resolve for you, may not. That can be a problem. And then security features are super sensitive to fully qualified domain name. As soon as you start issuing certificates against host names, you want things to match. Do yourself a favor, start fully qualified from the very beginning. These kind of errors are so common, I'll just read this off the slide. If you read through error messages in your Hadoop error logs, these errors are so common that the full link to the frequently asked questions is actually in the log line. I mean, it's there because people hit it all the time. So, and one last thing is to make sure you get your name resolution working before you enable any kind of caching for name service. If you've got name service cached wrong, you think your records are right, and yet you're hitting cache, things still won't work for you. You'll be chasing your tail for a while. So, this is the moment. Take out your camera phones. I'm going to grab a sip of water real quick. So number 1, disable VM swappiness. We don't want to swap. Number 2, mount your disk with a no A-time option. We don't need to record access time for things in HDFS. Number 3, data disks. Disable root reserve space and reclaim that disk to do more things. Your managers will be thrilled. You'll all of a sudden get, petabytes more out of your clusters, and they'll be like, "Where'd you get it?" You're like, "I'm good. I'm that good." Enable the name service caching daemon to reduce latency on your remote lookups. Increase your file handle limits. Number 6, use your dedicated operating system and logging disks and let your data disks do their own thing. And number 7, and potentially most important of all, use sane name resolution. And the links to the slides are right here. This is just a short link that goes over to SlideShare. Slides are there available for you. It's all there. I have no idea what time it is. This clock is not working. 12:11. All right, we've got time. So recommended reading. If you are running a Hadoop cluster and you don't have a copy of this book or have not downloaded a copy of this book, I highly recommend it. Hadoop Operations by Mr. Eric Sammer, formerly a Clouderain. Now he's with Scaling Data. I'll actually be giving this copy away. I'm not quite sure how we're going to do that. I'd say, yeah, first person to bum rush the stage gets the book, right? Here's what I would say. If you have a business card, drop a business card up on the stage. If you don't have a business card, write your name down on something and drop it off on the stage. I'll collect them all. And then right after this session, I'm going to walk over to the Cloudera booth, and I will draw one name out of the hat, and we'll give the book away. And if we can find Eric to autograph your book, we'll find Eric. Let's see here. So we have a little bit of time, so I'm going to skip this for a second because we have extra time. More stuff. Really quick. So with Hadoop, you've got all these spindles all the time. They're running. Sometimes you're not sure why performance isn't the way it should. You may think you have a disk going bad. It can be good to do a quick disk I/O check. You can do this via Linux. You can run hdparm, which does a basic I/O check. We're looking for at least 70 megabytes per second worth of throughput on an otherwise idle system. Don't do this on a busy system. Don't do this on a system that's doing other things. Take your system offline first. 70 megabytes per second from your typical 7,200 RPM disks. Anything slower than that, you've got a problem with a drive, a disk control, or something. You might think about replacing the disk, or that disk may be going bad anyways. I've seen some strange things doing benchmarking systems where we force disks to fail. You can also do this with DD. I'm not a big fan of that, but it is possible if you're more familiar with DD. This one, disable Red Hat transparent huge pages. This is kind of a mess. It's a little bit technical. Suffice to say, if you're seeing elevated CPU usage on your Hadoop cluster, you might consider disabling this and see what happens. There hasn't been a lot of problems disabling it and causing more problems, so give it a shot. There's a really good write-up by Greg Ron, also a former Clouderain, about all kinds of benchmarking he did with and without huge pages turned on. And I'm not as much of a kernel person to even know what most of huge pages means, but I know most of our customers have been turning it off and have been having better experiences without it. This one is a point of contention, jumbo frames. We argue about this internally between us architects and our engineering folks. I'm kind of a former sysadmin networking kind of guy, so I recommend turning on jumbo frames if your network supports it. Talk to your networking people. If your hardware supports it, your host supports it, turn it on. It's less packets that your kernel has to keep track of, more data in a single packet, less packets to keep track of, lower CPU usage for high throughput stuff. And I say easily and arguably boost throughput because I've had people tell me that I've done my tests wrong before. You know, I couldn't possibly have gotten this kind of improvement. Yes, sir.
It'll also help you with latency issues because you're increasing your packet data size per round
Yes.
trip. So
Yes,
it's
yes.
a big help for latency issues.
So the gentleman up here is saying that it improves our latency as well, since we're basically sending more data in a packet with less overhead. And the last thing, this is a no-brainer for you guys who have been around long enough. Monitor everything. You know, there are plenty of open source tools out there. Many of them have been talked about today and this week at Hadoop Summit. Use Nagios, use Ganglia, use CM, use Embar, use something, right? You need to know what the hell is going on with your system in order to know, is this normal? Is this abnormal? Are things working? Are they not working? And really only looking at this stuff over time will you be able to tell if it's normal for you. There's really, anyone that tells you that there's a set, cut and dry, this is normal for you, probably doesn't know what they're talking about. Every cluster is different. Every cluster has its own proclivities. So that is, I swear, the last slide, and we still have plenty of time for questions. So, and the obligatory, yes, we are hiring. If you love this stuff, if you love, you know, visiting clusters, getting people installed, getting people set up, you know, give us a shot. All right. I think there's a microphone in the middle of the aisle. If we could pass that to the folks who have questions.
Can you upload slides somewhere so that we can follow them?
Yes, the slides are up on the, it's tiny.cloudera.com/7steps.
Including all the steps after.
Yes, yes, even the bonus stuff is on. We are that good.